Question 13 is about a quadratic function, and they have the x-coordinate is a minimum point, or sorry, the x-coordinate of the minimum point of the quadratic is when x is 1.25. And we see in our function 2x squared plus kx plus 4. Clearly, having that variable k is a problem with the problem, and of course the first thing they're going to do is ask you to find it. Now, why is it crucial and important that the x-coordinate of the minimum is 1.25? Well, I can promise you, maybe promise is too big of a word, but when you have to find out like that middle term, k, I can pretty much guarantee that we're thinking about the axis of symmetry formula. And 1.25 being a minimum point means it lies on that axis of symmetry. No matter where the graph is, the axis of symmetry goes through the maximum or minimum. So they're giving you that piece of information. So essentially, to find the value of k, the axis of symmetry formula is negative b over 2a. And so I know that 1.25 equals negative k over 2 times 2, because we're talking A, B, C there. And so now I just need to solve that out and give myself a little bit of space here. This will be 4. So I'm going to multiply by 4, and that turns out to be 5 equals negative k, so negative 5 equals k. And so there's for part 1. And then they want you to calculate the y-coordinate of the minimum. So we know that 1.25 is the x value, the y value. Now we can substitute into that formula, and just for sake of making this easier, basically f of x, that's the y value. So I'm now just substituting what I know into the formula to find the value of y. And when I calculate that all out, I get y equal to, I've done the calculation and I find out that it is equal to 0.875. And so there is my y value. Now when we go to sketch the graph, and I've written the equation up here just so we have it with the graph. And they want you to sketch it so it's not perfect. The domain from -1 to 3, and there's the graph. Now, obviously the wise thing to do here is to put this into your calculator, see what it looks like so you have an idea. But there is one thing I can tell you right away that I know. 2x squared minus 5x plus 4, that plus 4, that is your y-intercept. So I already know, and I should mark that I'm kind of, 2, 4, 6. So there's 4. My sketch should go through 4. Likewise, I knew that from before, 1.25 is the axis of symmetry. So if I make this 1, 2, then my axis of symmetry should be going somewhere like that, if I drew that right. Oof. Let's make that straight. So there's my axis of symmetry, and the y value was 0.825. So if we have 2 here, there's 1. So somewhere down in there, that's where my minimum value should be. But let me first look at it on the calculator just to get a quick double check. And you will see, actually let me go back. So there's the equation, and I'm graphing it. Now, they've told me about the window. I do want to point this out. Their graph is from -1 to 3, so I've set my graph from -1 to 3. Their scale is from -6 to 12, so I set mine from -6 to 12. So I've made my window match the graph that I'm being given, so that when I do look at the graph, I have a good idea of what it should look like. And so I can see it almost gets up to 12 out here at -1, and it's about halfway up 6 when it gets out to 3. And again, I know there's my minimum point. That has to be 4. So that just gives me an idea that at 1, I'm going to go about up to here. It's a sketch. But it should hit some of those important points. And you should mark those on your sketch just to be a little bit more accurate. And yes, if I were drawing this straight on, I would want that to look like the actual minimum point. So there's my sketch.